We have 70 minutes to do a test.
Yeah, extended, right? I'm not making the test any longer.
So we're just lucky?
No, the decline of American education. That's what it is. All right, we only have to go over 5 problems. I doubt that. I think there's more. What does that say, help me? Who wrote help me? I can tell who wrote it just by looking at the faces. Morikuni.
Oh, that was not me.
Was it you?
I swear.
All right, number 2. All right. Okay, there is a problem on the test. I already told you. Yeah. I'm going to give you 3 points. You got to be able to write the equation of the problem. That's all it is, except this one got words. So when the diameter is 6, it costs $8. When the diameter is 8 inches, it costs $12. And then when the diameter is 10 inches, it costs $20. Write a quadratic function that models the cost of the cheesecake. In other words, write the equation of the parabola that goes through these 3 points. That's all it is. So all I have to do to make the problem harder is just make it turn it into a word problem. So what do? You just simply plug in these 3 points into this equation and then let your algebra skills lead you right to the answer. Do you want me to do it? No need, right? Okay, number 3. Okay, how many people got number 3? Just one person?
No, I thought I did, but I didn't.
Answer on the bottom. Cho? Chen? Con? Work?
It took long.
You got it then. Normally this problem is on the quiz, but it's not going to be on the quiz. And then didn't I tell you yesterday the probability of this problem being on the test now is 0.98. Oh, it went down to 0.98. Okay, so remember how to do this problem. In fact, if I'm going to let you use your graphing calculator for a problem on a test, that's going to be on this problem. So you have a well over here. Did you guys even draw a picture to help you? All you got to know for this problem is rate times time equal distance. That's all you got to know, man. All right, so here's the well. Although you don't see the stone hit the water, you hear it splash 4 seconds after you drop it. So what you're going to do is you're going to drop a stone. The stone is going to go down and there's water on the bottom. And then it splashes the water, but then the sound of the water splashing travels back up, and that takes 4 seconds. That must be a pretty deep well, yeah?
Yeah.
Okay. Use your graphing calculator to find the distance from the top of the well to the surface of the water. And then I give you some things that you should know. The distance that an object falls is given by, now if you guys are in physics, you guys know this, right? 4.9 t squared. Who's in physics now? You guys not doing kinematics and things like that? Where did this 4.9 come from?
Gravity.
That's 1/2 g, right? Because g is 9.8 meters per second squared. Whatever, it doesn't matter, I gave you the formula. And then the speed of sound is 340 meters per second. You guys know that from physics as well though, right?
Yes.
Okay, would you agree that the time it takes the rock to fall, I'll call that T1, plus the time it takes the sound to travel up is equal to 4 seconds? See, somehow you're going to have to write an equation with just one variable. Now, what do you want to call the height of the well, since we don't know it and that's what we're trying to find?
H.
Okay, H. I was thinking X, but whatever. Whatever letter you want. Okay, so the time it takes an object to fall is this equation. What is this X then?
The distance.
That's the distance it does. So X, or if you wanted to call it D, whatever, is equal to 4.9 t squared. Can I solve for t in that equation?
No.
What do you mean no?
Yeah.
Yes. T squared is equal to x over 4.9. So therefore t is equal to the square root of x over 4.9. That's the time it takes. See, we don't know the length of the well. Whatever the length of the well is, if you plug it into there, that tells you the time it takes to fall. Everybody agree? Okay, so the time it takes the rock to drop is the square root of x over 4.9. Now, how do I figure out the time it takes the sound to travel back up? Rate times time equal distance. What is the distance?
X.
X, thank you. The length of the, maybe we should have called it V, yeah? Do we know the rate at which sound travels? Yeah, it's right there. Sound travels at 340 meters per second, so rate is 340. Therefore, the time it takes the sound to travel up is X over 340. We just don't know what X is. X is the height of the well. So this is the time it takes the sound to travel up. So the time it takes the rock to fall plus the time it takes the sound to travel up gotta equal 4 seconds. This is your equation. Now, I'm letting you use your calculator to solve this equation. What do you think? Kawamura, what did you do?
I did different. I just made like the was it the distance that it travels down equal to like the sound distance,
Okay, that works as well.
and then I moved it all to one side, and then just put
Okay, good. Now, you get to use your calculator now. So, you know what some people were doing last year? They're just using their calculator to crunch the numbers. No, but can you see that if you were to solve this equation by hand, it would lead to a quadratic equation? Can you see that?
Yes.
You move this on that side, square both sides, that's how you get the x squared, right? But no, what did I teach you yesterday? You can solve any equation on your calculator. Do not even attempt to do anything with this. So what did I tell you yesterday?
Put it into the.
How do you solve any equation on your calculator? Make one side zero, Genji, Kikaida. So look, make one side 0. The hard part is writing this equation. Okay, make one side 0. Graph this on your calculator. Y equals this. Now, if you see that on your calculator, if you graph it on your calculator, on the appropriate window now. Don't just think you're gonna just press graph it. You're gonna see it now. You gotta make sure the window is so that you can see it. Wherever it crosses the x-axis, that's your answer. So you just go menu, function, root, and boom, it'll spit out the answer. Well, to me, this is the easiest way to do it. I'm sure there's other ways of doing it as well. Can you repeat this on the test?
70.
Well, the answer is on the bottom, right? Come on. 70 point something meters. That's a darn long well, right? 70 meters. That's pretty deep, man. So I remember, I forget, when was the last time I put this on the test or quiz? All I did is change the numbers.
Wait, what the heck?
What?
Wait, how do you, wait, you press plot?
Yeah, but you gotta make the window. You cannot, because depending on the window you have. See, a lot of people think, I'm just gonna graph it, I'm gonna start pinching. No, you gotta set the window. Okay, let's set the window. Look there. Okay, look. Let's set the window. Okay, what does x represent? Doesn't x represent the height of the well that we're trying to find? So what should I make x min? What do you think x min is gonna be?
X-Men.
X min. Okay, you know when you go shift plot, doesn't that give you the window? Try to do that, shift plot. Don't you get a window?
Yes.
Alright, let me see. Shift plot. Here, see? X range. X range or Y range. So what should I make my minimum value of x?
-10.
No, 0, because
0.
you gotta have a negative length for the well, right? Okay, now this is where you gotta kind of guess over here. You gotta guess, well, see, so what you do is you start with 10. So what I normally do is I start with 10, and then if I can't see the graph, then I go to 100, then I go to 1,000, 10,000, 100,000, a million. I just increase it by a factor of 10 every time. Okay, but what are we looking for? We're looking for the graph crossing the x-axis over here. So it really doesn't matter what you put here as long as it goes from negative to positive, right? So you can see it crossing. So try that. Do you see anything? Do you see the graph crossing the x-axis?
No.
Okay, no. So then try 100. Now graph it. Can you see the thing crossing the x-axis? If not, then try 1,000, then try 10,000, 100,000, 1,000,000, 10 million. But I think you should see it.
100.
Yeah, I know. That's why I'm saying you should be able to see the thing crossing the x-axis
And
now.
how do you get that exact point again?
Menu,
Menu,
function,
function.
and then root. Root is where it crosses the x-axis.
Got it.
I thought we were gonna finish early today, but we're getting bogged down on this. Just for that, the probability of this being on the test just went up, 0.998. In fact, it just went up again, 0.999. Notice I didn't say 1 yet. Number 4. We just did that problem yesterday. What was it yesterday? Airline tickets? I changed it to headphones and all hell is breaking loose. Oh my goodness, people. Okay, here's revenue. Okay, that's okay. We get it on video. It's fine. Now, normally, how much do you sell the headphones for? 24. And like I told you yesterday, I remember I put it on a test a couple years ago instead of that with Pokemon cards or something. And then, how many times are you going to get the same problem before you get it? Normally, you sell it for $24, and how many of them do you sell?
1,000.
1,000 of them, normally. But you realize that every time you make a $1 price reduction, you can sell 100 more headphones. So every time this price, this price goes down by an increment of $1, the amount of headphones that you can sell goes up by an increment of 100. Like that. That's it.
And then for the answer.
Okay, wait. Okay, so if I were to graph this, you would get a parabola opening downward, right? See, there's a maximum revenue right there. What's the fastest way to find the vertex in this case? Remember yesterday?
Half of
You
it.
look at the x-intercepts. So the x-intercepts are 24 and -10. What's halfway between 24 and -10? Rhymes in heaven.
10, 7.
7. So that means when x is equal to 7, that's the most amount of money that you're gonna get. But then you gotta answer the question. It says, what price will maximize the revenue? Well, doesn't this represent the price right there? So if x is 7, what's 24 minus 7?
17.
$17. So if you're a smart business person, you would sell your headphones at $17. You're gonna make the most money. Or would you rather sell it at $24 and make 0? That's how you go out of business, people. Okay, next, number 5. Everybody can do number 5 after I taught you how yesterday?
Yes.
So what if I kick it up a notch on the test?
Can do.
Like there's no numbers. Woo-hoo-hoo! Question.
What does the golden ratio mean?
You didn't even Google it then.
No.
Man, if I had something, come on, you guys have the power of the internet at your fingers. If I don't know what something means, I Google it. What about you? Okay, number 6, what does that mean? What does that even mean? Do all of it?
Yes.
Now there's many ways of doing it, but there's a good way and there's the long way. Like, how many of you did the long way? Like you actually compute what the roots are. How many people use the quadratic formula to figure out the roots, and then you did that? And it came out, right?
Sure.
But didn't it take like a while?
Yeah.
No calculator now. There's gotta be a better way. Yeah, and what did we learn in this chapter? I'll tell you right now, there is a problem like this on the test. So you're gonna have to know it. What did we learn? How many roots does a quadratic equation have?
2.
2. And what are the 2 roots? R and S. What did we learn? If you add the 2 roots together, you will always get negative b over a. Does that sound familiar?
Yes.
Yes. If you multiply the 2 roots together, you will always get c over a, negative 5/3. Now, can I use this to help me do these problems? You bet your bippy. Okay, I will do one of them for you. Pick one. A, B, C, or D. You know what? I will do 2 of them. I'll do one easy one and one hard one. Okay, I'll do A then. Did you guys do A? But did you do it the find the roots and then add 1 and then go back? Or did you guys do it this way? Okay, I see yeses and no's. Okay, so I'm looking for a quadratic equation whose roots are what? R plus 1 and s plus 1. Okay, these are the roots of a quadratic equation, okay? Okay, I don't know what the roots of this one are, but I just tried to write this. Well, if I add these roots together, r plus 1 plus s plus 1, in the new quadratic equation, isn't that equal to negative b over a?
Oh, still.
If I multiply the two roots together, shouldn't that equal c over a in the new quadratic equation? Okay, now, is there a way to figure out what these things are just based on these two things right there? You bet your bippy, because look, simplify this. Isn't this r plus s plus 2? Do we know what r plus s is? Yeah, that's 4/3. So this is equal to 4/3 plus 2, which is 6/3, and that's equal to 10/3. So negative b over a in the new equation has to be 10/3. Now, is there a way to figure this out based on these two things here? Yeah, let's try multiply it out. Multiply this out. Go. rs plus r plus s plus 1. Is there a way to figure out what this number is based on these two things here? You bet your bippy, there it is. What is r times s? Right there, look. Negative 5/3 plus, what is r plus s?
4/3.
4/3 plus 1. What is that equal to? Make the least common denominator. Negative 5 plus 4 plus 3. What is that? 2/3. So that means c over a in the new equation has to be 2/3. Well, look at these things right here. If you were you, what would you set a equal to?
3.
3. Then what would b be?
Negative
Negative 10. And then what would c be?
10.
2.
2.
So therefore, the quadratic equation that would give you these roots would be 3x squared minus 10x plus 2 equals 0. That's the equation. Now, some of you are probably going, Mr. Park, I just couldn't do it the way I did it. I'm going to use the quadratic formula. But see, here's the problem. What happens if I give you a problem and there's no numbers? Then you want to probably do it this way. Okay, now I'll do one of the harder ones. Which one? If I were you, I would ask, well, either C or D. Which one? Which one gave you the most trouble? I don't know, I didn't do either. Okay, I think D is a little bit harder. Okay, we're gonna write an equation whose roots are r squared and s squared. Okay, well, if I add the two roots together, you will always get, we're doing exactly the same thing we did back here. Negative b over a. If I multiply the two roots together, you will always get c over a. Now, you just have to ask yourself, is there a way I can figure this out just by knowing these two things right here? See, this is where you gotta think a little more. What can I do to this to get this? Well, isn't r squared, I'm gonna leave a space here. Isn't r squared plus s squared the same thing as r plus s quantity squared minus 2rs?
Yeah.
Yeah, but I never thought of that. That's because you gotta use these. Well, what is r plus s? Right here. That's 4/3, and then you're gonna square it, minus 2 times rs. Rs is negative 5/3. What is that? That comes out to 16/9 plus 10/3. Make a least common denominator of 9. That's 16 plus 30. Isn't that 46/9? Did I do that correctly? Yeah, so 46/9 is equal to negative b over a. Okay, what about this one? This is the easy one. If I know these two things, can I figure out what r squared s squared is? Yes, because r squared s squared, isn't that the same thing as rs quantity squared? But what is r times s? So that's negative 5/3 squared. That comes out to 25/9. That has to be c over a. So if I were you, I would make a, look at this and look at that. What would I make a?
9.
9. Therefore b gotta be negative 46, and then c would be 25. Therefore, the quadratic equation is 9x squared minus 46x plus 25 equals 0. Can you repeat something like this on the test?
Yes.
Like what if I kicked it up a notch and went r cubed and s cubed?
Same.
Yeah, you do the same thing except different. Okay, now, certain problems, we only got 5 minutes. Certain problems you can do other methods like this. Did anybody do this problem by thinking of what the graph looks like? Did anybody even do the problem? Okay, look. If I were to graph this right here, wouldn't that be a parabola? And where it crosses the x-axis, that's your answers, right? Those are the roots, right? Everybody agree? So I want to make a new equation where the roots are going to be r plus 1 and s plus 1. So if this is r and s, what can I do to the graph to make the roots r plus 1 and s plus 1? You shift the graph 1 to the right. Doesn't that make sense? Now, did we learn how to shift the graph 1 to the right? Yeah, so if you think of this as a function like this, how do I shift the graph 1 to the right? I'll give you some choices. Is it this one, or this one, or this one, or this one? Which one shifts it 1 to the right?
The top one.
Okay, very good, the top one. So all you have to do then is substitute x minus 1 for x, like this. So your answer is going to be x minus 1 squared minus 4x minus 1 plus 5 equals 0. Just shift the graph 1 to the right.
That's the math.
Yeah, that's the math team secret. And then you can also do the math team secret on B. Okay, so if you have a quadratic whose roots are r and s, what do I need to do to this graph to get the roots to be 2r and 2s? You gotta stretch the graph horizontally by a factor of 2, right? Did you guys learn how to do that last year?
1/2.
How do you stretch the graph horizontally by a factor of 2? Since we're running out of time, I'm just gonna tell you that, right? Wait, you had Mr. Rubash, did he do Mox and Max?
Yeah.
Mox and Max, Mr. Rubash, that's what he always does.
What's that?
Okay, how did Mr. Rubash teach you how to stretch and shrink the graph?
So you say compensation.
Okay, maybe he changed his ways then. Okay, anyway, that's that. So all you have to do is substitute x over it. So where's the original equation? Simply substitute that for x. There, boom. Just equals 0 and then simplify it. Okay, we got 2 minutes left. Okay, we have to do number 8. Okay, number 7, can you, oh no, is 7 up there? Everybody, so if you can do a best fit straight line, can you do a best fit parabola?
Yes.
Okay, you just gotta pick the correct one, yeah? Because when you're doing an experiment, what if your data points look like this? You gonna do a best fit straight line? No, because it looks like a parabola. You don't do a best fit straight line, it looks like that. Okay, we got 2 minutes, number 8. Okay, you know what, I'm just gonna start you on this, because I don't think we're gonna have time to finish. I'll tell you right now, the probability that this problem is on the test is 1. It has been for the last 30 years, I believe. How many people got it? Very good.
A.
Okay, here is a wire. It is 1 meter long. I'm gonna cut it into 2 pieces. The first piece is bent into a square. The second piece is bent into a circle, like that. You guys understand the problem? X represents the amount of wire used to make the square. Therefore, wouldn't that be 1 minus x? Everybody agree? Because I remember on the last time I put it on the test, I just changed it to the wire is 2 meters long. You know what happened? All hell broke loose. Find x, so the sum of the 2 areas is a minimum, is a maximum. Okay, so what we need to do is we need to write a quadratic function for the sum of these 2 areas. Okay, we got 1 minute to do it. Well, if this is x and that's the perimeter, wouldn't this be x over 4 then? Can you guys do that? So therefore, what's the area of the square then? Over 16. You guys at least got that, right?
Yep.
Okay, so this one, the circumference of the circle is 1 minus x. Can you figure out the area? Well, let's call this r the radius of the thing. So wouldn't 2 pi r equal 1 minus x? Therefore, the radius got to be 1 minus x over 2 pi, correct? So here's the radius. How do you find the area of the circle? Pi times the radius squared. Okay, let's see if you can answer the questions then. This is a quadratic function, right? How do you find the vertex? Negative b over 2a. So what you gotta do is you gotta multiply it out and do negative b over 2a.
And how do you find the minimum?
I'm not gonna tell you, I'm not telling you. You guys gotta think about these problems.
Darn.
Okay, we will start class tomorrow by finishing this problem. Yeah.
I cannot.
Well, you can't wait till class?
Oh, we can get it tomorrow in class?
In my class, you always get your quizzes and tests the very next day.